This lesson deals with Supplemental Problem 8.3. You can find this problem in the ECE202 ebook in the Chapter 8 Supplemental Problems on page 3. Can you find the phasor representations of the following time domain functions? 10 times the cosine of 5t plus 18, minus 8 cosine of 5t, 18 times the sine of 5t, and then lastly minus 2 times the sine of 5t minus 10 degrees. Now to go from the time domain to the frequency domain, we need to express our time domain function as a cosine function. This first one is just in that form, so let's do the phasor transformation. We use a capital script P for that. I'm going to grab the magnitude of 10 and the angle of 18. Now in the second case here we have a minus sign. We've got to get that minus sign somehow inside the cosine function. But that's just simply a phase shift of a plus 180 or a minus 180. You could use either one. It means the same thing. So now I've got my function as a cosine function with a magnitude and an angle. And so I'm going to grab those two to get my phasor representation. So 8 at angle 180. Now our next function is a sine wave. And I always forget the formula for converting a sine to a cosine. So I have to draw a little picture. So here's a picture of a cosine function. And if I want that to be a sine wave, I have to move this in one direction or the other. So to make this a sine wave, I need to take this point right here and move it to the origin. Okay, when you move a waveform to the right, it's a negative angle. When you move it to the left, it's a positive angle. So moving this a quarter cycle, which would be a quarter of 360, would be 90 degrees. But I'm shifting it again to the right, so it's a minus 90. Let's take this case then of 18 times the sine of 5t. So let's convert that to a cosine function by simply taking the angle here, which is 0, and subtracting 90 degrees from it. So our phasor then is 18 at angle minus 90. Our last case is a minus 2 times the sine of 5t minus 10. Let's take our sine and convert it to a cosine. So again, we're going to take the angle that's here, I'm going to subtract 90 degrees from it. Converted my sine to a cosine. I still have a minus sign here, so let's bring that minus sign inside as a plus or minus 180. Now when you add these two together, you get minus 100. And so I can add to this a minus 180 or a plus 180. I'm going to pick a plus 180, although it doesn't make any difference. But when I add these together, my angle will be between plus and minus 180. I find it easier to visualize the waveform in the time domain. And so if I add these two together, I get a plus 80. And so now my magnitude is 2 and my angle is 80. And this is Supplemental Problem 8.3.